Hello, this is Mr. Collier, and today we're doing arithmetic series and sigma notation. Okay, so let's take a look at this first example. You start running every day, 1 kilometer on the first day, and then an additional 200 meters, or 0.2 kilometers we'll call it. How long until you run a total of 20 kilometers? Okay, not 20 kilometers one day, but a total of all the days. Okay, so we're going to be answering this question in a bit. Okay, so basically what we're going to learn here today is the arithmetic series, which is an arithmetic sequence, but you're adding all the terms. So that's what a series is, when you're adding all the terms. Alright, so there you have, this is the notation. S1 is the first sum of the first term. S2 is the sum of the first two terms. S5 will be the sum of the first 5 terms. So 5 plus 9 plus 13 plus 17 plus 21 is S5, which is 65. Okay, we have two versions of the formula in the formula booklet for a sum of an arithmetic sequence. We've got this version here, which depends on n, the number of terms, and the first term. It looks very similar to this one. And the second one is if you know the number of terms and you know the last term. Okay, sometimes we don't know the last term and we can't use this one, but usually we're using this first one right here. Okay, so let's answer the question here. So we have U1 is 1 and D is 0.2, so we can use the formula to get the sum. How long until you run 20? So Sn equals n over 2. We don't know n, that's the number of days. And then we got 2 times the first term plus n minus 1 times 0.2. And we want to know when that equals 20 kilometers. So this is the equation we want to solve. Let's check it out on the graphing calculator. Okay, so let's type that in. Wonder if I can copy and paste this one. Okay, this equation looks pretty similar, so I'm just going to adjust this one. So we got x over 2, and then we've got 2 times just 1, and n minus 1 times 0.2. Okay, so that's the correct equation with x instead of n, of course. And then I'm going to graph 20. Actually, you can get a point of intersection on the calculator, but you can also, because n is a whole number, you can actually solve it by looking at the table. Okay, I'm going to look at the table and see when the value reaches 20. Okay, so we can see after 11 days, we have more than 20. Okay, at 10 days we have 19, and at 11 days we have 22 kilometers. Okay, so yeah, that happens on the 11th day. Okay, next, let's look at this example here. Calculate the sum of the first 20 terms of this series. Well, the D is going down by 3, so it's negative 3. And we can just use the formula. S20 equals 20 over 2 times the first term plus number of terms minus 1 times the common difference, which is negative 3. Okay, and that will give you 630 when you add all these numbers together. Okay, next we have find the sum of this series. This is a little bit more challenging because we don't know n. We don't know the number of terms, so that's what we had to find. And we could do that because we know the last term. And then we could solve for n. So we can use actually this formula in our formula booklet for the term un, which is going to be 90 in this case. So we're going to have 90 equals u1, which is negative 10, plus n minus 1 times d in this case is 4. The terms are going up by 4, so you solve this for n. So I'm going to add 10 to both sides, get 100 equals 4n minus 4. 104 equals 4n. N equals, if you divide by 4, you get 26. There's 26 terms in this series. Now you can do S 26. There's 26 terms. And you can actually use this version of the formula because we know the last term. So n is 26 over 2. The first term is negative 10. The last term is 90. So it's actually 13 times 80. Okay? It's simply 13 times 80. Uh, 1040. Okay. 1040. Part B. Find the least number of terms that must be added to get a sum of greater than 100. You can actually, since we already have that on our calculator, we don't have that on our calculator. Oh, I have it typed in up here. Okay, so I typed in the formula up here with 2 times the first term, n minus 1 times d. So you have the formula in here. And you can do it in the graph, but since n is a whole number, we can just find it in the table. And you can scroll up. You can look at you can click on number 26 here, and we get our answer for part A was 1040. But we want to know when it reaches 100, so you just look at when it gets more than 100, and that's after 11 terms. Okay. So it's after 11 terms. Or you can say just n equals 11. Okay, you can also add things up on your calculator in arithmetic sequence using this sigma notation. Alright, and this is just a starting value here on the bottom. And this is the number of terms. And this is the equation for the nth term, and it gives you the sum. Okay, so let's take a look at this one here. If you want to generate terms, we have 2 times 1 plus 3 is 5. And then if you do 2 times 2 plus 3, you get 7. So it's going to be arithmetic sequences going up by 2 each time. So we can use the formula Sn equals 7 divided by 2 times twice the first term, which is 5. Plus 7 minus 1 times d, in this case, is 2. Okay, and that should give you 77. We can also do this with sigma notation in our calculator. You can go to this button, click on sigma notation, and the bottom we can use x. I think you can use another letter. Let's use x. 1 is the starting value, and then we got 6. And then you can type in 2x plus 3. And also should spit out 60, but I made a typo. This is supposed to be 7 terms. And it gives you 77. So it's the same thing. Okay, this is the same sequence. The common difference is 2. General term is first term 5 plus n minus 1 times d. Yeah, so you can type it into your calculator this, and it spits out the answer. So when you have an arithmetic sequence, you can do it this way too, using sigma notation on your calculator.